Okay, so this is part 2 of that problem, number 14 in the homework. And what I did is the second part is asking us to find the density of the oil. And for that part, we'll use this information. The fact that when the object was immersed in oil, now we have an apparent weight of 279 newtons. If you haven't watched the first video, I suggest you watch it because I explain why I set it up like this. Because the text says something else. But this way works too. And I think it's not as confusing. Okay, so now we need to find the density of the oil. Let me just point out that this quantity is the answer from the last problem. Okay. So let's start with the buoyant force. Now we have a different buoyant force. I forgot the newtons here. We have a different buoyant force by the oil, right? The oil is applying a buoyant force on the object. So to find that buoyant force, we need to subtract the original weight of the object minus the apparent weight of the object. When we plug in our numbers, we're going to get 24 newtons. I saw that I forgot the newtons here. Sorry. Okay, so now we have the buoyant force. With the buoyant force, we can know the weight of the displaced fluid. The fluid in this case is the oil. So we can say that the buoyant force is going to be the weight of the displaced oil. And we know that weight is simply mass, in this case the mass of the oil, times the acceleration of gravity. And we want to use the mass because we know that density is equal to mass divided by volume. So that means if we find the mass of the oil somehow, and then we find the volume, then we can find its density. So let's think about the volume, okay? Well, the volume of the oil is going to be the volume of the object because the object is fully submerged in the oil. So the amount of fluid, the volume of fluid displaced of oil displaced is going to be equal to the volume of the object. Okay? So I'm going to use this formula because I said things without a subscript pertain to the object. So in this case, the volume of the object, with a little bit of algebra, we can find that the volume of the object is the mass of the object divided by the density. In this case, the density of the object, which we found in the last problem. And also we know that the weight of the object is equal to its mass times the acceleration of gravity, which means that the mass of the object is equal to the weight of the object divided by the acceleration of gravity, which means the volume of the object, which happens to be the volume of the oil too, is equal to this equation. This is a fraction over a whole number. We can clean that up very easily. So now we have that the volume is equal to the weight divided by the density of the object times the acceleration of gravity. Okay. Now let's think about the mass of the oil. Okay? The mass of the oil. Why would we want the mass of the oil? Well, because the density of the oil, which is what we're looking for, is equal to the mass of the oil divided by the volume. In this case, the volume that was displaced. Okay? So now we can say the density of the oil is equal to the mass of the oil divided by the volume. Even though the volume is we're gonna use the quantities from the object. So weight over rho times g. So that means the density of the oil is going to be the mass of the oil. I should have put the Greek letter first. Density of the object times the mass of the oil times the acceleration of gravity divided by the weight of the object. So how can we find the mass of the oil? Well, in this case, it's the displaced oil. What we know that the weight of the displaced oil is equal to the mass of the oil times g. If we solve for the mass of the oil, we'll get divided by g, that the mass of the oil is equal to the weight of the oil, which we have, divided by acceleration of gravity. Now we're going to combine our formulas. Oh, I should have written down this is density of the oil. Sorry about that. Density of the oil is equal to the density of the object times the weight of the oil divided by acceleration of gravity times acceleration of gravity, everything divided by the weight of the object. Of course, these two cancel. And our formula, our equation, reduces to a very simple one. So we have that the density of the oil is equal to the density of the water, sorry, not the water, the object, times the weight of the oil which was displaced, the 24 newtons, divided by the weight of the object, the original weight. Let's plug in our numbers. There you go. The newtons are going to cancel, so that leaves with units of kilograms per meter cubed, which is exactly what we want. Let's see what we get in decimals. I'm not going to round. I'm going to use the answer feature on decimals to get a more precise answer. And there you go. The density of the oil is going to be 666.67 kilograms times meter cubed. That's it.